with the JD's Garage CNC plasma table, and super successful, I have to say. So I had some other video and I had it on a bad SD card and I wasn't able to create a full video with it, and I lost it. But the most importantly is the cut and how it came out, and that is this cut right here. Look at that. So it was signed for outdoor kitchen, you know, has a outdoor pizza oven, grill, and all that stuff. This came out really nice. I didn't finish cleaning it up or anything. I did mess around with the feed rate on this one, and I didn't mess the sign up, but I did undercut it, which means I didn't cut all the way through in some spots. You can see right there, because I was messing with the feed rate. But once I got it right, you can see super crisp cut right there. Back looks good. This came out really nice. So since I lost that video footage, I did a time lapse, I did an intro, time lapse, and then the after the cut. I was super happy with it. Still super happy with all the cutting that we're doing. So I'm going to do another cut right now. It's another cut that was intricate, and I cut it out of steel. I actually cut it twice, and this was it right here. So just to get this done, originally when we didn't have our EMI management taken care of, this was a real pain. This had to be gone over many times, a lot of starts and stops. You could see, if I get in on there, you can see all the stopping and starts. Not very sharp, although at a distance it still looks good. When you get up on it, you could see where we had a lot of problems with cutting this. So it's a monogram for myself, and I did cut out a stainless steel one, which went well, but again, had some start stops and all that stuff. This was prior to fixing all the EMI stuff, and I want to try to cut that again in aluminum. Right, we want to keep cutting on this machine and making sure it's consistent, and I'm pretty confident that it is at this point. I go right through the cuts, like the pizza cut. That's what I named that. I call that the pizza cut. That went great. The cowboy cut went great, and it's much more intricate than your standard just, you know, make a CAD file of a part and, you know, cut some squares, rectangles, maybe a couple circles for some bolt holes and things like that. Those cuts are fairly simple. We can get through them. It's these intricate cuts, you know, designs and things like that, and we are pulling it off with this table. Again, here's our controller. Everything's working good. Air's pumping out of it. It's working great. Turned out perfect. So again, I don't see too much cutting on these bigger tables on YouTube. I'm trying to look around and see if people are, you know, frequently cutting on them, and I don't see that. I see a lot of cutting on the smaller JD's Garage table, like that one arm gantry style, single gantry, whatever you want to call it, style table, and but not a whole lot of cutting on the bigger table, and I always wonder why. Maybe there's bigger problems, I don't know. I would expect more cutting on these tables, especially if someone had built a smaller one and they were looking forward to building a bigger one. And you know what, I didn't look much prior to building the table as far as people actually cutting with the table. I always seen the cutting being done on the smaller table, and it never dawned on me to check out the cuts on the bigger table, which lead me to believe that there are issues out there, and maybe people just resolve them themselves, or maybe they just bag the controller and put a new one in. I don't know. But right now we're dry running this monogram here, right here. So we took that same file from the original steel cut right there, and we enlarged it to about 24 inches wide, and I'll probably put this on the front gate, something like that, or hang it on the wall in the basement or something along those lines, just because I think it's cool, and because we can, right? The table so far is, the water table is a mess, so I believe after this cut, or maybe after this sheet of aluminum is done, we're going to do a video of the drain down of this table, the water table, and a cleaning. So my plan is to drain the water into a plastic container down the bottom, you know, from the ball valve, vacuum everything out that isn't magnetic. You know, we'll go through it with a magnet first, take all that stuff out, and then we have some more green stuff right here, and we'll freshen it up. But I do see why people drain their table, because that stuff I think is like 50 bucks, 60 bucks. And that is exactly, so the table itself, I believe it's 20 or 25 gallons, but that 1 gallon of that takes care of this table when it's full. But anyway, we're not here for that, not yet. We want to see this bad boy cutting and spitting out a nice product. So that's what we're going to do. I still need to follow up with you guys on the controller, the inside of the controller and the wiring. Quite a few people reached out and they want to see some more detail on that, and where things are landed and why and whatnot. So we're going to go through that too, but for now we're going to put this on a time lapse and we're going to get it going, and then we'll do a after cut. Stick around. Alright, ladies and gents, the cut is done, and it went flawless. No glitches, no freezing, no stuttering, no stopping, zero interruption. Zero. That went spectacularly well, right? It's my own fault. This is my own fault. I should have filled the table up higher. Now, especially when you're cutting aluminum. Now, I know you don't want to you don't want to fill the table up to the point where you're trapping the bubbles under the material. That's when you have that whole explosion thing, right? And you start to trap them in the water table's high, you trap, air bubbles are trapped under the material, and then boom, plasma comes down, kablooey, right? But what I did here was I had the piece of metal, you'll see it in the laps, and I just tried to hold down the material here, but super smooth cut. Wish I had the water higher, that would have made the difference between the material staying more stable and not warping as much. But everything seems to be cut through. The table got a little high. The metal was warping, but all these pieces are coming out here real nice. Just like so. Alright. Everything is cut through nice, except where the metal came up and the tip got too close to the material. That's where we made a little boo-boo. So I was contemplating on filling it, but I also kept in mind that I'm going to be draining this to clean the table. So this still went really well. Look at that cut. Look how smooth. If I could keep the, you know, I know what I got to do. I made the mistake. That's my fault for not filling the table more, knowing that I got to clean it. But we could shake this out. Everything is pretty much loose here. Get the center of the G out. Got plenty of scrap aluminum. Alright, so see that there? That's our biggest. The rest of it's all good. It's that spot where it's really started to lift. But this has nothing to do with programming or the torch. This is my own whatever you want to call it. Right. I figure instead of putting another 10 gallon in there or whatever it is, that I'd get away with leaving it low, and I shouldn't have, because this is a pretty big piece. It's kind of dumb, but this will come out. I'm gonna need both hands. I gotta get back to you. Give me a minute. All right. Woo! This is just, it gets better and better. And it gets better and better because I could just pump a file in the open build right from sheet cam, and it just does it. It just, now it's just getting it done. It's just putting in work right now, this little puppy. And this is the product. And it came out better than I thought after the cut. I just wiped it down. I didn't hit it with any abrasive scraper or anything. I just wiped it down because it was wet. And look at the cut. That's the front. This is the back. Look at that. It's a joke. Like, the front is so crisp. It's so, look at the stuff. It's just falling off. Look at that. Just falling right off. Beautiful cut. The front just falls right off. It looks like it's jagged, but it's not. It's super sharp. You can just clean it up with your nail. Look at that. Oh, look at that. You can literally get a plastic scraper. Look how tight that is. Come on. Even the places where I didn't cut all the way through, well, not that I didn't cut all the way through, but the tip was dragging here because the material was moving. I just have a little bit. Look, it comes right off too. Ha! That's awesome. And you can actually see, look how clean that is. That is incredible. Incredible. And then the back. The back. Some of it doesn't have anything on it. So that distance, like right here, that was like the perfect distance. Right? From face to tip to material. Perfect. Just incredible. And this stuff, you can literally take it off by hand. Or what I've been using is this scraper right here. and you can just put it right on the edge, just like that, and it comes out just as crisp as the front. Look at this. Stuff comes right off. This is a dynamite cut. Look at that. Even the spots where it came up a little bit more, you gotta use a little bit more effort, but that's it. Ladies and gents, we got us a CNC plasma table that works and is working consistently. So now we're actually, let's see, how many cuts have we done since the EMI? So we did the door cut, which was this. Again, no hiccups, no flaws, no nothing. We breezed right through it. Came out great. And then we had the cowboy cut, which was phenomenal. And the friend that I gave it to absolutely loved it. It's like a perfect size. 24-inch sign is kind of, it's a really nice sign. For indoors, outdoors, man cave, whatever. So we had the cowboy cut. We had the door revision. We had the cowboy cut. We had the pizza cut, which I'm still upset that I lost that footage. But that went just as good. This doesn't have, look at that. This came out great. Another winner chicken dinner, right? And then we have the monogram, which looks fantastic. There it is. We'll put a couple holes in it. Let's do a little, let's put it on a back. This would look great on like a black background or something along those lines. But let's put it up against this wood here and see what it looks like with the wood behind it. Like if we were to do a that looks good. I am envisioning like a cherry stain on the wood. Real nice as a background, and maybe backlit too. This is awesome. And definitely when you're cutting stuff like this, it's definitely better to go bigger, because you can smooth the cut out more, and you can get in here and you can really tool this in if you want and get it really I mean, it's crisp right now with just a little scraping to get off all the little fuzz. Now I got fuzz all over there from the rag, but look at that. That's not even any pressure. It's just coming right off. Look at that. You could probably put a buffer wheel on and take this off, or even probably a green scouring pad. Let's try that. It's probably that minimal where this is going to come right off. I'm super pleased with that. Super pleased. I'm hype. Woo! Oh God. Ooh, look at that. Look at that. We can go one direction and give it a nice brushed look, which I can do that with the sander, with the belt sander. That would be sick. Or I could just do it with this. So say, oh, look how good it's coming out. I can hit the sides first, knock off all the heavy, and then just finish it off. Look at that. Are you kidding me? Oh, what a wonderful feeling. I would definitely wear gloves when you're doing this, because doesn't mean the edges aren't sharp. They're super sharp. I mean, this is so crisp. Look how crisp that's looking. Woo! Oh man. Oh, I'm excited. This would look even good with like swirl marks in it, you know? But we can give it a nice brushed aluminum look as a finish. And listen, this blows away the other rinky-dink thin metal signs that they're just trying to sell out there. I think people would pay a premium for a nice aluminum monogram that's not going to rust, and they don't have to pay through the teeth for. But oh man, it just keeps getting better. It just keeps getting better. Look at that. That is perfect. The pizza cut is awesome. Guys, girls, ladies, gents, we got us a table. She's cutting, and she's cutting consistently. Perfect. Now it's just dialing in, you know, taking care of the stupid stuff like filling the water table up all the way, so your metal doesn't warp. But I'll tell you what, if we had the table, it would just be even better. You know, the metal will be cooler. That tip, we keep that tip at that consistent level, and literally get this cut to where it has no dross like this. You could actually, I can actually push the dross from the back forward, and if I do it enough times, it's gone. And I could probably get our green scouring pad again, and look at that, it takes it right off. A little bit more, because it's a little bit more, but my God, come on. That is crisp. Crispy. And again, I will say the 0.9 tips, 50 psi, 2,000 millimeters a minute on the feed. Let's see. The feed's 100%. We don't mess with that. I didn't mess with the jog. The only time I mess with the jog is when I do the manual. I call the manual cuts. When I'm cutting the pieces, the excess off of the sheet, to make it consistent. Because what will happen is you'll end up with stuff like this, and if it's heated, it'll warp and it'll pull it up, and it'll do all kinds of wonky stuff, and it'll throw the height of your metal out of whack. So this has been super successful. Definitely, I couldn't be happier. We're cranking out some signage here, and we are going to do another project, which I'll give you a little sneak peek. Woohoo! Hello. We're going to try and turbo our 94 Ford inline 6. I always wanted to do it from back in the heyday. I never got around to doing it, but now this is even better because I have the table and I can cut whatever custom pieces I need, bracketry, whatever. I can make an intake cap, you know, the hat for the carburetor. I can do all kinds of stuff now. This is awesome. And yeah, look at that. Come on, we got it under control. We fixed it. And I have to say that we are running, well, I got a mini split in here, so the mini split's running, these lights are running, These lights are running. The garage door opener, the fan was running. I had that going. You know, we got our plasma cutter going. Our Sunstack 50C. She's a little Mighty Mouse cutter, getting the job done. And yeah, so we will be addressing one thing, and like I said before, during the build, and I noticed, I kind of figured it would be a problem. And not that it's a problem, but it's kind of dumb not to address it. Let me bring the gantry in here. Okay. The top gantry, after we did the side rails, decided to make this stainless steel, which was the best move as far as the chassis build. So this here, no issues at all. Look at it, it's beautiful. The only thing I do with it is I grab the green scouring pad and I just clean it up, because it gets a little bit of that like white funk on there from the water splashing up, especially when you're cutting the aluminum. Okay, you'll get this kind of stuff here, right? So with that being said, the side rails are steel. Let's move this out of the way. Other way. And I'll show you, especially since we're cutting aluminum and we were keeping the water table really high, we end up with some ugly rust accumulating here. And it's not just, you know, if you have high humidity in your garage and you're not in here and you're not conditioning it, you know, and it's high heat outside, you have the humidity, you have the water from the table, and then heat in the garage, and then the humidity level gets high. And you end up with stuff, you know, like this. And you have to clean it more and more. It really needs to be conditioned with maybe a silicone spray or something. But rather than do all that and worry about it, the top gantry here is so much better and smoother than the steel. Because even the steel, I tried to clean this up and hit it with several grits of sandpaper to try and smooth it out. It's smooth out, it runs nice, it's smooth. But as far as like longevity, if you leave the table sit, the steel is going to get all buggered up. Even if you just paint, even if you paint the majority of it and just leave the corners like the JD's garage, it's still going to get, if you leave it bare and you have humidity and stuff like that, like you can see, it's getting all buggered up. And I'm not going to go through and paint it and all that. I'll spray some silicone on there, maybe rub it down with some graphite spray, something like that. But the real thing that needs to happen with this is these sides, these rails need to be stainless. It's not a whole lot more as far as money. And to be honest with you, if you're going to be building a table this big, I would definitely do stainless steel on the rails, all of the rails. Doesn't have to be that thick. You can see here I still have some left over, but I just don't have enough to do both sides. But it's not quite 1/8 inch. I think it's like 10 gauge or something like that, or probably thinner. I have to check my build sheet, but super successful. I hope this helps, and I hope this helps everyone build the confidence that they need to continue to build. And despite what some of the people say out there about the controller or this and that, you can have a really good end product as far as the table is concerned. That is going to put out, as you can see here, is going to put out a really good product itself, you know. Let's move the gantry forward here. This way we can display the sign. Fancy, fancy. And once again, there it is. It looks great. No interruptions, no hiccups. And I can tell you this. I am going through the tips for the torch are lasting much longer, and I doubt it's because of the aluminum, because from what I hear, the aluminum itself, you know, there's a lot of spatter and everything with the aluminum, and I hear it tends to bugger up the tips more. I can tell you with the EMI stuff situated now, the tips are lasting longer, and the reason why I'm thinking they're lasting longer is because of all that intermittent, you know, the torch itself, you may not see it, but if that controller is being interrupted by that EMI, you could guarantee that the tip and the signal going to the torch, you may not see it, you know, clearly, or see the failure like that to where it's obvious, but that doesn't mean that it's not pulsating and the voltage isn't stable to the plasma. I noticed that after the we corrected the EMI and the power, and now we're on Bluetooth and we're not feeding through the USB, the plasma coming out of the torch is much more crisper, very, very sharp, and it's super consistent. There's no little fluttering or nothing like that going on. Before, it was kind of, I won't say sporadic, because you have to see the before in order to realize the results after. It's one of those things. That's how, I guess, how can I say it? You're not going to pick up on it very easily. You're only going to pick it up if you know the difference between the way you were cutting versus how you're cutting now after this. And I can definitely say with 100% confidence that the EMI, even though people may not be feeling the effects of it on their tables, I can tell you that the plasma and the cut quality will suffer. I know that these cuts here that we're making are far sharper, smoother, very consistent in comparison to the way it was cutting. And you can see, based on that other monogram and some other things that we were cutting, you could just see the inconsistency in it. You know when it's right, and when you know it's right, like now, you can really tell when it's wrong, if that makes sense. And I'm going on and on because I'm really happy with the way this turned out, and super excited that we were able to rectify the problem. I want to continue to cut this way. I can prove and continue to prove that what we did is essential. It must be done in order for you to have, especially with this size table. Again, I think they're not feeling it as much on the smaller table, but this thing is massive. I mean, it's a big table. And we're not using super high quality stuff here. We're using Amazon controllers. We're using Amazon plasma cutter. You know, this thing was $149, and you guys see how it cuts. But I think even if you had a high dollar plasma cutter, if you had interference, you're gonna have problems with that cutter. Now, is the interference less with like a hypertherm plasma cutter? Yeah, absolutely, because they take the additional steps. That's why it costs, you know, a couple grand or whatever it costs, because they take these steps to minimize the EMI that comes off of, you know, the plasma cutter itself. For $149, there's like one ferrite in the and it's on the wires of the display. I can actually show you here because it's open. Here you go. So it's good to break stuff once in a while. But that's the only one you have. And this is the one that's going to the display, and that's the only thing it's protecting is the EMI, you know, for the display, so it can display properly. But the rest of it, it doesn't have any protection. There's no foil, there's nothing. This is as bare bones basic as it gets. Blowback, non-high frequency, you know, plasma cutter. I don't think you're gonna find a cheaper one out there. You are gonna spend a little bit of money on the machine head, this puppy here. But I have this, I explained all this stuff in another video on what that torch model number is and all that stuff. But it's a legitimate blowback, and it, as you can see, not pulling no punches here. This is what we're using. And talk about keeping under budget. Usually, if you were to build a table like this, you're going to probably spend 1.5 times that on a really good plasma cutter, like a hyper thing. You know, I was actually looking at one before this, but I said, you know what, for this amount of money, for this plasma cutter, you know, why not? Why not give it a shot? And I did, and I bought it twice. Like I said, I broke the first one out of frustration. But super excited. I'm kind of pacing back and forth now, trying to figure out what we're gonna cut next. But listen, guys, we got us a table, and it's cutting, and it is cutting real nice, real nice. There it is. That's our product right there, ladies and gents. Hang in there, like, subscribe, and we're gonna do some more cutting. And we're going to prove this table, baby. That's what we're going to do. Alright, take care. Till the next video. We're probably going to do it on the inside of the controller. We're going to use our little... We got us a little... My son gave me this. He's like, why don't you use this to do some pointing out? So we're going to use this little puppy right here. He let me borrow it. And we're going to go through and point out what we did on the inside the controller. We'll get some light on there. This way you guys can follow it if you want to follow it, and have a super reliable CNC plasma table on the cheap. Alright guys, till next time. Like, subscribe, hang in there.